Okay. What? Ah, here we go. I don't know. Default microphone was changed. Okay. Ah, here I am. Hello, everyone. You have been too early today. 7 o'clock. At last time, last time was already 8 o'clock. Central European summertime. We had great weather today. You should. Wow. Oh, I need to. It's still reading back. It's still hair. Yeah, this is my greasy hair style today. No sound. Why is it still? Oh no. I still listen to the. Okay, okay, okay. I need to mute it. Okay, so otherwise I can't talk. Okay, hello, Tech, Adam, Ray. Oh, Ray is early today. Johnny, Dave, M40K, Dodge Taurus, Rota, and Max. Oh, all the MVPs today. Kasper, hello. Hannes and oh wow, Alexander is also there, and that's it. Okay, now ah, Jordi, where's Taxman? Huh? Jordi, Wumpus, hello, hello. You had what? Snow? Yeah, bitluni is reading back all the chat to me. We are almost there. We are almost there. It read back all the stuff. Okay, here we go. Uh, all the usual suspects. Yes. So, peeps, I had a visitor today until like 15 minutes ago. What? What is fixed? What is fixed in? Okay, we had like really good weather today, and I was hiking with my friend that was visiting me, and yeah, but it was quite freezing in the morning. I had like to like scrape off the ice of my car window, but I took a nap in the evening, so I should be fine for a few hours of stream today. Yeah, no, that's all right. Yeah, but Looney should read back the chat because otherwise I wouldn't notice what your people are talking about. So, what happened last time? What did we do? Oh, no fondue, by the way. I just had pizza, so I can do. Yeah, yeah, that's what's happening. Let me turn on the camera. Is the camera? Why is the camera not turned on? Is it turned on? Oh, it's off. Okay, here we go. So, last, yes, there's so. Do you want to see my desk? I will dox my desk so you can enjoy a view of my desk. Now this is no fondue season isn't over. It's just oh yeah, no fondue. Wait, desktop face. That's not what I wanted. Microscope. Wait, no. Here we go. Okay, let's leave that. Um, yeah, I don't see a video here. Oh yeah, that's screen capture. Here we go. No, it's not that. Okay, here we go. That's that's what am I done? Yeah, that's where I tried desperately for the Makercast to get my microphone working. Then from being cold, the really tasty cherry things. Oh yeah, that's the blade. Bitluni's RISC-V cluster blade. We saw that before. Oh yeah, the matrix. These are not my matrices, but these are my matrices. You saw them. You saw them. Oh yeah. This is what we coded last time. Short recap last time. Yeah, I have the suspicion that the bus that we lose packets quite a lot, and then once the packets somehow align with the stars, we receive it. So you can see this is like what we coded last time. I think I even improved the speed, but I had occasions where the actual speed happened, where the packets were properly aligned. So I think between like this IC that's sending and the packets that are receiving, we somehow need to align it better. So this is that. This is that. And oh, and I also found a mistake. So one code to the you mean this one? No. It's a lot chips for a few LED. Yeah, no. You forget that this, okay, each of the chips has its own LED, and then on top of that we have 80 GPIOs, of which we have 16 ADC. It's not channels, it's actual ADCs that can work at full speed at the same time. And there's of course some the bus that we can still access to see what's actually happening there. And yeah, that's not fully plugged in. This is the supercluster. Huh? This is he got them cheap. Yeah. Yeah, 14 cents I paid for one of those. So actually block? What are you talking? Okay, so the BOM cost of this okay. BOM cost of the front side is like below, yeah, no, it's actually $2 for 16 MCUs, and the BOM cost of the back is also probably $2 because of the connectors, which are they're probably like 30 cents each, but still, like with PCBs and so on, that's probably $4 for a supercluster of 16 MCUs. Ultrasonic Doppler thingy. Interesting. So, did you come up with any suggestions what we could use this for? I could suggest, because it's not like super fancy. They don't have even multipliers. Yes. Well, I could sell kits with those, but put it on the list. More power, people say. More chips, more power. You mean like these many chips? Like look at the traces. We get some color shifts with the traces here already. That's also a 4-layer board, by the way, because it's so many GPIOs here. These are you can put 16 of those, which will make an LED matrix, and on top of that 256 that will be 256 MCUs with 1280 GPIOs and 256 ADCs, and that's the mega cluster. Here you go. Are you happy now? How many is too many? Doorstop. Oh, 64. Yeah, like on. Oh, oh, that's a good thing. And what do we call it? By the way, I have to brag. Oh, I got the Lear. 19. It should fit 90. Yes, yes, I could, but then it will be you'll be laughing. The addressable LEDs, they aren't cheap. So actually you could use an MCU, a separate MCU, or I mean you can use, oh, I calculated it, 8 by 10 LEDs, RGB LEDs can be addressed by one of those MCUs, like here. So look at this, we have 16 by 15, so it's 8 by 5 in 3 colors. And oh yeah, oh, wait, is this the one with the, no, this is the one with the program. Yeah, oh yeah, that's 180 frames per second in 8-bit color depth. Charlie plexing. I optimized the hell out of that. Now I'm demonetized. No, that's, I can power it. We noticed last time that I can power it from a CR. Yeah, that's Johnny's. Okay, 3 volt. There is an if I remove, okay, that's with 3 volt battery, and it still works, but I have a charging circuit on here, and the charging circuit is made for the Lear, which is up to 4.2 volts. So that's actually better because you could recharge that with USB like that. Now it runs even from that. Now it should be recharging. I think it should be. I'm not sure, but certainly I'm not sure if that's properly working, the charging circuit. It's like the first charging circuit that I put on the board myself. And yeah, if you have like a 3 volt battery in here, then obviously you can't use the USB to charge it. I'm not sure what to do. Maybe I will do a LiPo version, but then I can ship it. Yeah, probably I can ship it. I can ship it with the lithium battery. So I might just use like the light version. Oh, I will use a different. I ordered different connectors or different battery cases already. Let me show you the battery cases that I ordered. Where is my LCSC? Which are better. I ordered them today because I'm not happy with the. Also, oh yeah, by the way, that's interesting thing. Maybe if you're interested, I can show some tricks. Maybe if you are interested, some of the. Yes, but we will be back soon. Okay. Oh yeah, that's CH32V003. That's the IC. 20 GPIOs. Yeah, Charlie plexing this huge matrix. I didn't try the. Oh, by the way, I picked the right. These are the right buttons. I tell you, they feel so well. And I think we could even like put a case around them. They had enough profile to be still pressable. So if you have like a thick, like old man fingers like I do, they're still good enough to be pressed. Look like that, like my bouncy thumb. still is capable of pressing those buttons quite well, and you get like, I don't know if you can hear it, ASMR. They feel really good. So I picked the right ones. And one thing that I used like 16 GPIOs I used for the matrix, and then I have like 2 GPIOs that I can use for the buttons and the sound, or with this switch for the USB, which isn't implemented yet. There is no native USB on that IC, so that needs to be hacked. But that's what I made the bitblip for. So here, this is version 0.1, which I messed up since I pulled D- to ground instead of to 3.3 volts. And oh wait, that's the second version. This is the first version. The first version even has an LED, but the second version, so this needs to be botched. I have like 30 of those. I think whenever you meet me, you can grab one of those. You can still program them with the programmer, but USB, unless you botch it, I don't botch like this small resistor here. Like I think it's the center resistor that needs to be pulled to VCC. So I need to, like, I don't know what to do with that, like thumbstone it or whatever, so it doesn't touch the ground pad, and use this pin as 3.3 volts. But it works fine. I had a showcase even. I had a blink already with that one. So this is cool, like a mini, and it's purple. That's cool, huh? Bit split. Yeah, there's the second version doesn't have the LED anymore and has different pinout even. So I have like 3.3 volts and 5 volts on this side, and ground, and only the D and C GPIOs are routed out. So you could actually almost do this, like this matrix can be done with the pins that are routed out here. That's Charlie flexed only with these 16 pins that are routed out on this small PCB, which is really cool. I have an idea what to do differently. So this might not be like, it's already cool. It has a, like, you can hang it to like clip it to a keychain, but I think that will cause some shorts on this circuit, especially here. This is like positive, and here is like a chance, like if you bridge the ground and the positive, you already short a lithium battery in your pocket, which isn't nice. So that might be an idea to things that you don't think about. You might want to put a case around that. But I think like with the 3-volt battery, that wouldn't be like a huge disaster if you short anything in your pocket. Cluster chip, plastic lid. Yes. What? Max? You're spot on. That's actually what I looked for yesterday evening. Lanyard, you know, the phone lanyards with the clips, they are completely like plastic. So I don't want this metal clip, like, let me grab the lanyard that I get from Supercluster. Where is it? I got a few. I had them held it in my hand before today. Okay, they have like usually this metal clip. And there are the phone ones. I show you what a lanyard is. Oh yeah, this is what I want. Wait, this is what I want. I didn't know that I had one. Okay, so usually, oh shit. Yeah, a quad. Yeah, this is like one with usually metal clip, but I didn't know that I have that. This is one where. Why are there 10,000 cables? But I have actually one with this. That's one that I can use. Let me show it here. Actually, I looked yesterday for a long one. So for a long one, but I don't want this clip, I think. This is, I don't know if I actually want only like this. Oh no, is this metal? Yeah, but this is metal. Okay. I want one that has only like this part, which is easily, you can easily attach it by like threading it through the hole, like that. Okay, blop. And then you can even run a animated GIF like Rickroll and hang it off, like, and show off your achievements here. Whatever. That's cool. Yeah, that's what I looked for. I want like a bitluni style one. Yeah, nah. I really don't want to. Really, I should concentrate. I learned my lessons from trying to do too many things at once. I just want one function, and whenever I decide I need one function more, I can still do a second version, and I can sell things twice to you. Shill, the shill factor. So, but I'm still at this thing. I'm editing the video right now for this. So yeah, I love this. This was completely assembled by JLC, and works right away. Shiluni, yeah, completely assembled by JLC. So except for that, I wanted to show the part that I bought. I should have used that from the beginning. I'm distracted. Here we go. Let me show screen capture. I hope I don't. What is this? Why is this? What is this? That's here. Okay, yeah. Now, yeah. Now you see things that I ordered. Oh yeah, that's the small switch, which is really cool. Yeah. So what I initially planned for that, I made this. I can show one that's not using. Okay, so this is like a double footprint. You can see. Okay, this is. By the way, there are like through holes. For what was the through hole here? Oh yeah, that's the key for the switch. The switch has a key, but it doesn't matter. This is like ground here, and so it even overlaps with the USB, and even connected to the. So there is like direct connection between the shield and the ground here. So actually that was fun because this overlapped. I have like DRC warnings because of this battery pad here on the back. And this is like a double footprint that I made in KiCad for taking on one side. Where's I held it in the hand here. Like the cheap ones that I already have, I have like 200 of those here that are like, it's somehow stupid because they are too high. I might think, even though they say SMD, I might think that they should like somehow plug in or something. They were like really cheap, but completely SMD, so they wouldn't need like the carving like here. So if you have like, let's say you had only the matrix here, and you don't want a protrusion between, because you can't have on the other side you are full of LEDs. This would be one of the battery holders that would work because they're soldered on. So I used the pad for that, but I also don't like them very much, and I would rather like using these here, which are like nicer casing. You can see here for batteries. You probably saw similar ones, but this one, there are some without protrusion, and this one has like this nipples at the side here. I don't know if you can see that. So, and these slots here on. So this was interesting to design, like a small challenge. The slots here is where this like plugs in, but it doesn't completely go through the PCB. It's like only 1 millimeter, and the PCB is 1.6 millimeters. And I had to place the buttons. Do you see the slot there? The slot is between the legs of the buttons here as well. It's like really close. I don't know why I left like this, the pad on this side. I should have removed the pad, because then I would have more clearance. But I placed this battery connector footprint such that it barely doesn't touch any buttons. Yes. It's crazy. But you know what? I'm stupid. Because that's like, if you look, like this is, you see, like, oh yeah, super smart decision doing it like that. No, 3D printed, but who does that? I don't want to manufacture anything. I don't want to touch that. The most thing that I want to do is maybe program it and test it that it works. That's all that I want to do. So you think, okay, doing it like that and putting it between the buttons and so, it's so smart and so well done. It's stupid. It's stupid at the end. You know why? Because, okay, you can see the price. The price for this is, like for this connector is, where is the price? Show me the price. Show me the price. Here. Unit price 9 cents. Huh? That's the unit price. And then I ordered 10 of those to test it, just for a different game. And then you have this here, which is completely SMD. So you don't need any slots or whatever. You can plug this in. You don't need this huge pad. And this here is 15.5. It's 6 cent difference. And in bulk, it's even less than that. Yeah. Come on. It's like, let me check the bulk price. So let's say I manufacture only 100 of those. That's like 6. Wait, what's the price? Oh wait, which one is it? Yeah, that one. 15 quantity for 50 will be not even 13 cents. It's like 12 point what cent, and so we are at yeah, way thicker, but you have also, so I have trouble removing the battery from that slot here. You need to like somewhat use a pen or whatever and short it, and we can check how thick it is. Let's compare it with that. I mean, you can have the version 1 if you like. It still uses. Okay, okay, this gets cheaper. It's like 8 cents, but the difference is like only 5 cents between the two parts, and the other one is way better quality, and you have the freedom to use it with like designs where you can't put a slot in that. I mean, there are some ones that have only like solder-on pads, so there are ones that have right angle on that, like 2 pieces. I saw them as well. So you could use a similar thing to this one here. But really, what's the difference? Let me check. Let me check the height. Okay, we have 3 millimeters. 3 millimeters height here on that one, and then we have this one with, what is it? Okay, 5.5. It's 2.5 millimeters. Come on, guys, we can live with that, can we? That's all right. I think this is a better choice. Hey, Mike, Joe. Oh, we have a few more people joined. Nice. Okay, so that's like the idea. I will try it. I will try it. Maybe I will do also a combined pad again, but really, it might be okay just to use that. I don't want headache. And there is like with the plastic thing, you have less chance to like short stuff because you have only like the pads are smaller, like that. It's like the chance of shorting stuff is smaller. So that's the idea. Okay, yeah. Now let's talk about our thing. I've completely forgot how to code this. Oh, by the way, look at the programming jig. So this is the programming jig for these things, and I just, these are pogo pins here. Focus, pogo pins here, and pads here. I might want to do them true hole pads. It doesn't really matter, because like this is my development version. Yeah, metal. Yeah. They are crappy, I must admit. And I need to like, I can remove the battery by like doing like that. So this is like for the one that constantly are connected. But then I made this jig to program them on because I had some issues programming that. I just it basically aligns. This like even first try. I printed it and first try it's all right. And this is how I can program it and whatever. There would be a cool like if I can like use some sort of fixation so I can leave it in there, the programmer. Well, that was like in Blender, made in Blender in 20 minutes. This cool thing, and I have plenty of pogo pins. Okay, so that was that. This is for my hair. All the stuff. So many designs. I need to finish one project first. So we made a protocol last time. Let's plug it in. Let's plug in also the programmer. Where's the programmer? Here, that's the programmer. Programmer, and the programmer connects to 3 pins here. So, oh no, 2 black wires. No, that's not a good idea. I use 1 clock. I forgot which one is which here. We should just, oh wait, let's assume this is the clock pin, data, and ground. That's the main CPU, by the way. And this is here, this side, ground. Back in a few, what? What? Okay, CLK. That's the one. Okay, I think we can program that. Oh, ah! Huh? Huh? Oh no! The pin broke off. Let me remove that. Yeah, crappy wires. Here you go. I should throw it away in the bin already. Okay, here we go. Ground. Let's ground it. Otherwise, we mess up things. Okay, I can zoom out. I want to try. Here is the USB cable. Beep, boop, beep. Here we go. Oh, I love the Lear batteries. Why don't we use that more often? Okay, they're not like look at this, 40 milliamp hours. That's not bad at all. I think they can only you can only like draw 50 milliamps from that, but we can try with like at some point I will try with the speaker because that draws the most current, we learned. I will try with that and we'll see if we can use it even with the matrix, but because now I'm drawing like maybe 100 milliamps from each row at the same time. So okay, let's code. What is this? Moon River Studio. 40 milliamp. Yeah, but I mean, the rechargeable, you can still recharge. You plug it in. I tried it. Brian's PCB3s. Hey Maya. Yeah, you're experiencing the supercluster doing its work. Okay, here we go. Megaplex. What is this? What's happening here? Why is this so awkward? Yikes. Where's this other project? Megaplex Blink. Whoa. I need to reopen it. No, still awful. Oh, yeah, the tree. Okay. Here we go. Didn't we have like, wait, oh, so many things. Just close all others. Close others. Okay, let me check something. 1, 2, 4, 8. That's all right. That's all right here. That's Megaplex Blink. Wait, Megaplex is that's the wrong project. That's my mini console. Okay, we need to go back. Other solutions. Cheaper. Oh no. Where is my? Okay, I need to find the project first on my hard drive. Didn't we store it? Why is my head so hot? I'm getting hot right now. Okay. RISC-V cheapo megaplex supercluster. Okay, here we go. This is the right solution. Let's go. Beeps, let's go. Yeah. Okay, what I found is there is like, we have a clock divider by 4, which is not great. So we need to fix that and remove this clock divider here. So we might increase our speed of our device a little bit faster. Where is that? Let me make that small, and zoom. Whoop, whoop, whoop. Here we go. Okay, did it compile? Yeah. Unused. Yeah, I don't care. I completely forgot how coding works. Okay, now it stopped communicating. We need to update the small ones as well with the same speed update here, which will be Supercluster. Here we go. And, oh, wait. That should work. Chip type doesn't match. Okay, let me restart. Weren't we able to program it? Nope. Oh, wait. No. Huh? Who is right? Who is harassing me here? What's the sound? Who is sending me sounds? Ah, here. Okay. Oh, yeah, that's a difference. That's a difference. Ay. Is this the one with the slot? No, this is without the slot. This is the one with the flat profile. So what do you think is better? Flat profile or that could be even flatter. I don't know why they made the base so thick on the plastic one. Okay. Somehow I can't program the devices. Read protect enabled configuration. Ay. It's hard to program them. Oh no, didn't we? No, it looks like it could be the 5.5 millimeters. Okay, it appears, my friends, it appears that I can't program. I thought I can program them all at once. At least that worked last time. Oh, here we go. Yes. Okay, it's faster. It's 8 times faster. Okay, here we go. Now, because I think we can send way faster than that, there might be a problem during, like, for the alignment of the packets. So we should try to see how many packet misses we get. How do we do that? How do we show? I completely forgot how the code works. 1 week is a lot of time in my world. Oh no. Okay, this is the toggle. Okay. Let's say bus state idle. Okay. If not comment, okay, then it switches to receive. Bus state pre-receive. Then we have like we wait for the You don't see anything. Here we go. Sorry. So once comment is pulled down, if we are in the idle state, then we receive. Then we wait. What was the reason that we released the? Oh yeah, because we want the beginning of the comment. Yeah. Okay, that's the reason why we released comment. Okay, so bus state pre-receive, then it waits for the clock to go down, and then if we are in receive already, wait here for another clock for whatever reason. Not clock, then data index, and then oh yeah, if the clock and not last clock. So we waiting for the clock to transition from low to high to receive the data, and then if we detect that our, why is the data index 18? Oh yeah, sender receiver plus 2 bytes, the type. But oh yeah, you missed maybe last time. Maybe I should. Hello, Ray. Maybe I should recap how the bus works. Easy. We have command, we have clock, and we have data lines. That's the data lines. These are like eight data lines here, and they're all high all the time because that's an open drain bus. And once someone starts to send, it pulls that down. Then the clocks goes down. This is then released at some point, just for the first byte. Then when this clocks goes up, we have the first data byte, and we need to, let's assume that's like the first data byte, and then we have like next data byte. We have not like DDR or whatever, but like this. Boop. It's clocking out, and at some point it's idling, and then transmission is over, and everything is high again. Like that, and we receive the data. The first 8 bytes are the ID of the sender. So let's call it SID. Then we have followed by, that's like 8 bytes. 8 bytes. Receiver a good one. 8 bytes. Receiver ID. If it's 0, then 0 equals broadcast. All. Okay, that's the protocol, more or less. If there is a collision, it's detected here by the sender ID. Basically, a lower sender ID. No. Lower sender ID wins. Yeah, we discovered that lowest sender ID is dominant. So my friend visited me today, and he just said, "Oh, that's how the CAN bus also works." So basically, the one that's pulling down wins. and the other one has to go silent until the other one is done. So actually, we reinvented the CAN bus. Yeah. Obvious, huh? That's reinsurance that I am not that bad at what I do. And yeah, that's strange, yeah. But we have like an 8-byte ID. I don't know what CAN bus uses as identifier. Yeah, that's that. So we are here. So we have like only one CPU's the main MCU down there is sending right now, and the others are receiving, and it's basically brute forcing through all the possible IDs as a receiver, and that whenever the MCU with the specific ID receives a packet that's addressed to it, it will toggle the LED. That's what's happening. And it seems like this one here specifically has a different ID. And we are only comparing, I think, the first byte or something. Yeah. Here. We one wire? Okay. So actually, this one, we are comparing only like 1 byte, because that's like, otherwise we would have to brute force for ages. Okay, so still, I think we have packet misses. And how do we detect clock, if not clock idle, wait. Okay, not clock. So we have bus state else. Wait a second. This is wrong. Clock should be high. We start counting. Oh, wait, yeah. It resets the idle state of the, so whenever the clock is down, it resets the idle state. So for our comparison here, yeah, we know something's going on if the clock is low. That's why we reset this countdown for the clock. And idle is just plus, and yeah, we reset the communication, but we turned that one off if we don't receive for too many clocks, like the idle state. Oh, well, remarks. This is the remark. This is the remark. Okay. Yeah, I can add this. You should start. Okay. Or someone is sending boss not idle. Okay, idle. Com timeout. Count timeout clocks. Okay. Okay. But also, how do we stick? Let's check again. If bus state is idle, for how long is the comment? When is the comment checked? Comment is only checked here. We could also restart. We can restart the comment, so we don't. If we didn't like see the end of our transmission, we somehow missed it. Like here, we deactivated here right now. We don't wait for the timeout, and there's like still some state that we are hovering in. We might miss like packets. So how about we just do the code tells you how it works. That's how it. Okay, so if bus state is idle, or let's say CMD and CMD and not CMD and the bus state. We don't want to reset it, so pre-receive. What? And bus state. Yeah, let's do that. And bus state. So one thing that we want to ensure is, okay, if there is like still communication going on, but comment is low, comment will go high as soon the communication starts. So we just reset everything. And also we need this is what we want. This is what we want, okay? Let's maybe upload it already. Okay, let me unplug it. Come on. It's so hard to get it programmed. I should implement a method to upload to flash the devices. Why did it work last time so well and now it's oh wait. No? Yeah. Close link. Oh, come on. We had fewer problems programming it last time. Maybe the other array is more suitable to do it. Oh, read protected. Oh, now we are in a good state. Look at this. Now we are in a good state. Here. Yes. Okay, now let's check the main. This main here, how we send idle. Okay, comment out, clock out, comment out is 1. Okay, bus state send. Okay, so we before we even set clock out, comment out is already 0. So I still don't get why it's so slow with the states here. There's not many packets throughput. What is going on there? Why is it so slow? How many ticks are we using? 1,000? Can we use it faster? No, we don't want to, huh? 100 ticks is not good. Let's oh wait, we need, oh, this one needs to be slower than this one here. This one 400, yeah, that's we can go faster than this. You know what we should try? I will get the scope and we will see how many packets we are sending out. I have to be sure that we are yeah, my life. Okay. Fashionable hairbands. Oh, that was a compliment. Thank you very much. Yeah, that's because that's only for people who are too lazy to go to the hairdresser. Has nothing to do with fashion or anything. Yeah, that's a good comment. To do, fix that, and then no other information. That's the best. That's the best comment. Okay. I lost this here, but okay, let me put on. Yeah, but putting in to-dos is not bad because some IDEs even like highlight that, which is cool. Okay, let me check. Where is ground? Do we have ground here? Upselling for upgrade, for speed upgrade. Ground. I think this might be ground. I hope it's ground, otherwise we short the. Okay, now we need the, where is the bus? The bus system. Phew! What is that? No, that's not comment. Okay, I need KiCad. KiCad, save me from. Oh yes, KiCad. Okay, KiCad for the win. We have clock and comment here. Oh, let's check out the clock. I'm curious what frequency we get on the. Woo! What is that? That's some clock, my friends. Okay, clock says. What? Wait, that's only 17 kilohertz. What is that? That's... Okay, no wonder this is so slow. That's only 17 kilohertz clock. What is going on here? What? No way. Do you know the what no way guy from TikTok? What divider on what probe? Do you think so? No. This is the sender clock frequency. Ah! And nobody got clock for that. Okay, let's check what's wrong with that. Oh wait, no, we changed the divider already. Huh? What is this view? Okay, here we go. Let me check that. 17 kilohertz. Sometimes it's longer. Probably that's no. Wait. We need to count the bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, then some odd every few. What is this glitch here? We have like a glitch that shouldn't happen. That shouldn't happen. Okay, I want to see. Oh, you know what? I can use a second probe for the command pin, which will be cool. Then we have a complete view. Do you have ever had a I don't know what you're talking about. Single line of code. What are you talking about? What is this magic code you are talking about? Okay, here we go. This is the second. So, okay, let's run it. Okay, what? Wait a second. Didn't we That's a transmission start. That might be a bug that we even see anything because we needed to transfer. Wait a second. This can't be. That's a transmission start. Everything we see here might be just a bug. Do you see that here? Here, do you see that? This is a transmission start. This is a transmission start. Oh no. Shit. Oh wait, we're sending 1 byte at a time. Ah, that's all right. No, that's all right. That's all right. Wait, we're transmitting 18 bytes. Let's count again. 18 bytes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Ah! Whew! Okay, this is correct. We might want to attach the logic analyzer, huh? But why is it sending so slow? So how many packets do we manage to receive? What's the, wait, 1 kilohertz is a frequency for, so it says frequency 2 is like 1 kilohertz. So that's why we see the toggle. Okay, so problem is it's slow. The protocol is working because that explains why it's blinking so slow. We get, how many blinks per second is this? Is this 2 blinks per second? Then it would match with what we see. Because if we have like 1 kilohertz packets per second, and we are brute forcing through 256 addresses each like series. So for 1 blink of complete matrix, we need like to run through all the IDs to turn it off and on again. So we are at half a hertz. No, 2 hertz. Is this 2 hertz? That looks like 2 hertz. That could be 2 hertz. So we don't miss any packets. What we are missing is the speed. Okay, I'm glad to see that it seems like to work more or less okay-ish. But now we need to find the speed. Let's get the speed back. What do you think? What do you think? Should we try faster speed, faster error? We improved it already by 8 times. Now we need to find where the speed is. What are you talking about? 2 unconnected vias. Okay, let me check if we are HSI. Okay, that's 144. When I turn this off, okay, let's calculate what theoretical speed we should have compared to what we got now. Should we use sheet or should we just use the calculator? Okay, 144 megahertz divided by what do we have? This is our clock. What is this? 16 times 16 times 16, okay? That's like divided. What's 16 times 16? 265. 16, 4,000. Okay, let's do divided by 16 divided by 16 divided by 16. Okay, that's 35 kilohertz. Okay, that explains a lot. Megacycles, yeah. Not great. Not great. We might want to implement an external trigger for the packet receiving part and then do like super fast transmission. Okay, 35. And we get, no, that's correct. That's correct. Look at this. So we need like two clocks. We have 17. Oh shit. I zoomed too far. That's too big now. 17.6 kilohertz. That matches somewhat with the 35 kilohertz because we need for one cycle we need like one up and one down, which is double the speed. Okay. We just need to check if we can go faster. Should we, how fast can we go? Okay, with this one here, with this device, I use a frequency of, no, I count with 128 clocks per cycle, which doesn't do much. So I would use 256 cycles maybe to process all the data. Yeah, we can only quadruple that. We can quadruple that. Let's try quadrupling it, but that's not fast speed, huh? Quadrupling that. So divided by 4 is basically 400, yeah. Chip type doesn't, oh no, I'm at the wrong chip type here, this one here. Huh? Chip type doesn't match. Let's try again. This is the right one, Supercluster. Okay, it halted. Now I should be able to read protected. The clock speed is 48 megahertz, but we lose quite a few clocks for I don't know what. In that case, probably just for the interrupt itself, you lose like 64 clocks almost, because it puts some registers on stack and so on. So unfortunately, clock is this thing is slow regarding to that, but we can't improve it with the tick counter anymore, any more than that. Oh no. Oh, okay. Huh? Why is it still? Oh, yeah. There is no timeout. Now we switch to the other one. Why do I even switch the ground? The ground can stay where it is. Oh shit. Cancel. Now we can reprogram the big one again. Okay, this is now blinky 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 blink. 4 times faster, but it might actually lose packets. We don't know for sure. Let's check what the oscilloscope says. Oscilloscope is confused. No, I'm in some store. Yeah. Yeah, it's not like it misses packets sometimes. I see that it misses packets. That can happen when the tick interrupt takes longer than expected. So if you see, it's not like sometimes it's blinking fast. What is going on with this here? No zone. Okay, here we go. Okay, yes, that's 7 kilohertz packets, but it's too fast for the small MCUs. We lose packets here. Otherwise, it would be more synchronous. Whacking. No, that was only the handle of the oscilloscope that flipped over. Ah, my friends, what do we do now? What do we do now? Do we leave it like that and go on with our work? We can halve the speed again. Let me do that. Ship. Yeah. Oh, wait a second. We can just... Yeah, that works. That works. Okay. So I can lower the speed of the main CPU, and then the other ones are fine with that. If I restart it, it should. Now they're in this state. I just need to unplug them. Okay, here we go. Oh, this is the same scheme that we saw before. Okay, nice. We got now, yeah, 35K for extension cards, graphics cards, audio interfaces, keyboard interfaces, mouse interfaces. That's like a mini computer for you, my friend. Okay, so our current transmission speed, let's calculate it. Our bus speed is, with that settings here, bye-bye. This times 18 bytes. Yeah, okay, so transmission speed is 600 kilobytes a second currently over the bus. It's not like the best so far. I mean, we have still time. We have still like chances to fix stuff. But I would rather try to do proper communication now, because we are only sending in one direction. Oh, I need to plug it in, otherwise I lose my TTS if I don't recharge my phone. Okay, this is currently the fastest we can go. We can probably go a little bit faster, maybe 50%. That's true. That's true. Could happen. Could happen. Oh, that's a use case. Should we pitch the use cases for it? Okay, 16 channel audio interface. Who wants that? Or 16 channel. We have 16 ADCs plus like four extra bits per MCU. Okay, let's. I mean, I need to pitch some ideas. Oh, okay, nice. Yes, that's good. Yeah, I can delete this. Datei neu. No, it's lost. Okay, all is lost. No. That's not fast enough for the scope or whatever that should be or whatever. Wait, no, yeah. logic analyzer. It could be like a 16 channel, what bitrate? Yeah, 16 channel, 4 bits audio. Oh, PWM? Yeah, no, that could work. So 10-bit DAC, ADCs, unfortunately only, but like an 8-bit like SID sound. So we can have the following. Look at this. We can have 16 ADCs, and then we have 64 digital pins. DG. We can do like, out of that, we can do, that's like, we can do sound card 4-bit audio times 16, because yeah, that's the DACs. Like 16 DACs are 4 bits. That's what you can get here. Otherwise, we need to combine, like sync up two of the third version of this device will have more resolution. I promise. We will get 16. This one has like 5 GPIOs. The next one will have 16 GPIOs. No, wait, 8. I'm sorry. We have, oh no. Yes. Or we can sacrifice ADCs for that. So we can say, instead of that, we can have the constellation like 5-bit DACs. Let's say 8 ADCs. 8 ADCs, and then we can have 16, no, 8 5-bit DACs, which is really crappy. It's not that great, huh? Or we can, okay, I mean, it doesn't need to perfectly align, but what we can do a sound card. So one of the slots covers 4. That's cool. Okay. Oops. Let me get that. Okay, we have per sound card that we can plug in there. We can have up to 4 sound cards, and one sound card can have, listen, 4 ADCs, 4 ADCs, and then we can just get 4 channels uh, 4 channels, a 4-bit, which we can combine somehow. How do we do that? How do we add 4 channels of 4 bits? How do we add current? How is this working? So we can make like an audio in, audio out, whatever thingy. Or 4 channel 5-bit sound card. We can do like one that's only input with ADCs. Oh no, that doesn't make sense. How does PS2 work? Too much logic. I just want like passives on there. Yeah, we can do some sort of how do we add the voltage with an op amp? Are we just using an op amp adder? Let me check that. Yeah. Arithmetic circuits. Summing amplifier. Okay, substructure. And that's stupid. Okay, so apparently this is how it looks like. That's an adder. So we can use like 4 op amp chip and use 3 op amps just to add this and get an amplified output even, which is nice. Then we need a display connection. So we need a graphics card. This is like a sound card. Then we need a graphics card. Graphics. Does it work? Yes, that could work. But then you need like to synchronize the ICs really well. Oh, we could use shift registers. Oh, I have DAX that works like that. Oh no, I have stereo 16-bit DAX with that work like shift registers. I used them before on a project. Here. That's it. Oh foo! That's easy. We can do like 16-channel output and 4-channel input on one sound card. This is madness. This is the IC. Foo. Okay. Yeah, that's a good idea. We can use that. That chip costs like few cents. Happy dance. Yeah. That's the IC. No, that's not the IC. That's not the IC. Oh, yeah, that could be the IC. Wait a second. LM, no. I think this was PT. Yeah, that's the one. The LM is the amplifier. That's the IC. PT, whatever. And I have, look. I have plenty LMs, whatever it is. Crazy. Oh, my friends. Do you remember the old times? The old bitluni times where I etched my PCBs. These are one of my first decks that I made. Ah, isn't that cute? 8-bit decks. You just plug them in the breadboard and they work. Isn't that cool? These are like 100 megahertz decks. Yeah, nice. Okay, we have a plan. We can, you know what? We can even mill the PCBs if we want to. This is cool. Okay, sound card. Should we plan out the sound card even though the bus doesn't work, because looking at the coding doesn't do our favors? Or do you want to code a little bit more? I rather like to plan the sound card. Hey bleep. Okay, so Doom. Okay, who has PS4 specs? I think we can do like an input-output thing. Or wait a second. Should we do a MIDI port as well on there? A sound card with MIDI port? No, we went audio port and then we do like an extra sound, extra card for that here. Why is the focus not there? Oh, I can turn off the noisy. Focus, my friend. Oh, here we go. Okay. So, this small thing. So we have four, that's stupid, here, four ADCs, so 4 audio inputs. So ADCs per card. Then we have, do we use 16 channels? We can use 16 channels, or oh no, we can't use 16 channels. We have the let me get, because we need like a pin to shift. There's like a few, there is an enable and shift and whatnot. So we need at least like 1 pin to shift. So we don't have like stupidly, where is it? Deck. Okay, now I need to check the specs of the deck that we got here. Oh, my eyesight is worse. I can't read that. Oh, by the way, I got a new microscope holder. Okay. 8 to 11, PT 8 to 11 it is. So PT 8 to 11, I used it with ESP 8266. PT 8 to is Dr. Bachler. So what we are doing is here, we have for now we have like, the protocol isn't very fast. It's like only what's the speed that we calculated? Yeah, 600 kilobytes per second over the bus. But that's the including overhead, unfortunately. but we can communicate like from the main to the MCUs, and now we are planning for the extension cards here, because we have 4 cards that we can plug in side connectors. We can mill them, and now we are looking for use cases for this small supercomputer, supercluster. And one of that would be a sound card, because we love sound and we have plenty of ADCs. And one of the slots has... Oh yeah, really? Yeah, true. Now we can use like shift out data. Oh yeah, that's it. That's I2S even. We have hardware I2S on this IC. That's 1 bit. Oh, wait a second. We can even use DMA for that. Oh, what? No way. Let me check. Please. I hope I got the right pins, because a reference manual. That's I2S and... Oh, peeps, everything is coming together. All our hard work. Oh no, it doesn't have the big brother has I2S or not. Serial peripheral interface. Wait, here, main features, shift register, data. No, that's SPI. I2S. No, only the big brother. We need to, but it's not a problem. We can still emulate it. I did it with the same with, let me check. So I'm right. Where's the I2S here? I know I saw it in the reference manual of one of those ICs. So the main CPU may have like, yeah, DMA ADC. Wait, the ADC certainly has some. Oh, there is an analog. Yes, it will. It's like a computer. A complete, but oh, it's so fun. Isn't it fun? And I think if we make this a kit, a similar one, like it can be like on one board, and then people can just share all the firmware there. We just need to get a proper way of programming it, because now it's a hassle to program that device. It's just luck that it works. Yeah, there is the I2S feature. Okay, smaller brother doesn't have I2S. No worries, we can still wing it. And this is word select. Okay, word select and clock can be shared. Flash storage is per MCU is 16 kilobytes, but the big brother on the bottom has a lot more. Let me check how much storage that got. You can connect a drive to that. Oh no, it doesn't have a storage. Okay. So listen, this is what the GPIOs are for. If you want to have a drive, that's a good thing. Yes, that's a pitch. Let's do a list. Where's my list? Supercluster pitch list here. We have a bus spec. We do a TXT. Yes. Keyboard. We will do MIDI interface, and maybe. Oh, I don't have a PS2. device or anything. Load. Oh, wait, this is USB host here. Yes. Okay. Yes. Yes. Arbitrary binaries. That's we can use an SD card, or I mean, we can. Anyone can develop anything. You can also just attach an ESP32 to an expansion card and do a communication over this Wi-Fi card. Something like that. I don't know. Stupid. Okay. Okay. Use case. Okay, I will do use case. Use case file. We need sound card. Card. Okay, sound card. Then you said flash card. Oh, you can see that. So SD card. Oh, Lunibus. Maybe Wi-Fi card. Wi-Fi card. MIDI card. MIDI card. Okay, that's already 4. We might be able to combine a few. Pink link extension. That's a good one. Yeah, yeah. Pink link. Pink link could work. This one it has a USB host, so you could actually attach a drive there. I can show this. Maybe we have USB. It has some native support for USB. Wait, here. USB controller. Okay. USB host function and USB device function. Full speed hub. Broken. What was that? Oh, I shorted it. I shorted the bus. Oh no. Oh, thankfully, look at this. This one, I think this is clock or bus, and it touched the USB connector. Fortunately, that's an open drain bus, so it doesn't break anything. It just stops. Okay, here we go. That's funny. Yeah, yeah. Oh, it's all your fault. USB, 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 stuff. There's, yeah, that's on the main MCU down there. That's okay. Full speed. You can basically connect like external hard drive to that if you like to. Oh wow, that's a lot of, I don't know. Oh shit, that's a lot of stuff. Oh. There's maybe an example. Let me check if there is an example for that. Example, flash, GPIO, USB file system, UDisk library. Oh, yes, yes. Here we go. Look at that. Okay, we have examples, and there is a UDisk. What's the README here? Oh, nice, Chinese. Okay. But there is the SKU disk. Is this like a drawer? Oh. Let me check that file. USB host transaction. Oh, wow. Oh, I need to test this once. I didn't test any of the USB examples. That would be really cool to see if that really works. Oh, but there is like a library to that. Look at that. That's like, wow. That's a huge library that's precompiled. Interesting. It's probably licensed. No, I hope it isn't licensed or whatever. I will just use it. Okay, that's file sys udisk. Host udisk. Ah, there is the project for that. We have used it. MTP file system. That will be. Oh yeah, that's interesting. This is that we can use for the device that will appear like if I connect it to a PC, we can drop on the firmware for these things. That could be nice. Yeah, yeah, it could be. Host. What's KM? Is this keyboard? It's also host. Oh man, there are so many examples. I didn't even know what I did here. I mean, that could be keyboard mouse. Oh, nice. Okay, we can actually connect this is a host. Host. What is IAP? What is IAP? Do you know what IAP is? What is IAP? Host demo code drive enumeration and USB drive enumeration and operation. Read in the root directory inside the USB drive to write to location. After successful check, write the flag data, then jump to the user code. The code will run IAP first to check the flag data, then if the preparation data is normal, it will jump to the user code. Otherwise, if the compiled data is okay, it will jump to the user code. If not, it will stay IAP again. What? That's cool. That's like file system OTG host udisk AIP. That's like firmware uploading over do I see it right? Okay, there are quite some examples. I'm looking forward to test all that stuff at some point. That's like, oh man, we'll be doing that for ages. IAP. So can you plug a storage device into? Plug a storage. Okay, so it will basically you can update a flag there. No, it will run code from the storage device. Is that right? Jay, please explain, because there is not much documentation except for this one comment in the code. IAP, we can use ChatGPT to find out what it does. Okay. Explain IAP to a kid. Okay, here we go. In-app purchases. Oh, that's not it. Plugging in the storage. Okay. As nah, it doesn't know this IAP. Oh shit. Let me check that. What is this abbreviation for? Ah, identity aware proxy. Okay. Security feature that some websites applications protect their resources, works verifying, identifying things. Okay, this is not what we expected. Are you? What is this? Oh, take. But it's cool. I mean, if it just runs code from a flash drive, then you can just basically get a bunch of flash drives like program cartridges and just plug it in and run it. The problem that I still see is how do we do a graphics card? We need like an good chip. Yeah, there are drivers. There are drivers. Certainly there are. That's what. But it seems like they're not open. I must just udisk library. There is like this file which is huge for udisk. But like the whole host thingy, that's interesting. Like there is a bunch of the things there. File system USB-D. What is this? Okay, composite keyboard mouse. Compatibility human interface. Simulate CDC human interface device. UDisk CD-ROM. Do we want to try that? Are you interested in trying any of those? We can upload it on this device to see what's happening there. Simulate human interface device. CD-ROM. That's crazy. Yes, yes. There is like so this one here. Maybe I can show the dev board. This is the CH32V203. which has two USBs, like full speed USB, and it supports host and device. So you have simultaneous USBs, which is really cool. I don't know if it if there is like a hub support implemented. That's like another story in that driver. It could be because WCH is like they made a ton of USB stuff. Self-flashing, okay, that's cool. Oh, that would be nice to have that. Yeah, but you need to upload it anyways. The base needs to be programmed and then you plug it in and it will flash the stuff. At some point I need to implement. I think this will be the topic for the next time. I don't know if I'm like, yeah, if I have enough energy left today to start writing a flashing routine for these devices over bus, because it would be nice to have a way to write like the code without using the programmer to the devices. Basically, yeah. Okay, I think any more ideas for the expansion or for the use cases? So MIDI card, Wi-Fi MIDI. I mean, we have USB, so actually we could even yeah. Do we have the debug interface on the bus? No. The debug interface is not on the bus lines, so it's separate. But I can only I'm lucky if I can program the. You see, I have to try a few times to upload the code to all at once. Here. To all at once. What we can try now is we can try getting some code to use the serial on the 203 USB. There is like wait an public example, and basically clone that USB device, simulate CDC. Is this what we want, CDC? Is this the serial? Let me check. It added the project here. Let me check what it does. RX deal, yeah. So we have USB lib, yeah, that it uses the library. I might need to copy that library then, because otherwise USB lib, USB driver. Oh wait, no. It's all config. Wow, what is that? Power config. What was that? Yeah, okay. UART and printf. Okay. So we can use this UART, which is nice to communicate with our main thing. Let's just clone that stuff and put it, or let's try to upload it first to our device, even though it will stop now. I want to see what's happening, simulate demo. Okay, let's compile that and see what's happening. And then we will just take the USB CDC to our computer, and then we can try. Okay, the goal for today is this is not our goal. This is not our goal. We did open collectibles, make hardware, whatever. Protocol, COM-tests. COM-test is done. Blink pattern, yeah, we did that. Let's handshake protocol. Mandelbrot shade. This is like nope. Okay, yeah, that's like far away. Let's do CDC. Okay, let's put on a to-do list CDC, and then let's do fetch IDs and print. And oh yeah, handshake. I don't know what. Okay, this is our. We just want, because now we have only one-way communication. Now we need the small things to talk to us, and we never did that before. So we need to communicate the other way around, and we need to get the CDC working. Let's try with the CDC first. It's programmed. I mean, it compiled. Now let's program it and see what happens. Do I hear anything? We have a serial port here, I think. Serial terminal. Is this? Embedded, yeah, okay. No, that's not. Is this even? I didn't hear a connection sound. Let me check to plug it in again. If I hear anything. Nope. Is this even working? Oh, my phone dropped out. Oh, thanks for noticing. I don't know why it did that. Because it's stupid. Ah. Okay. Okay, let me check the device manager. And no, that's the CH link. So that thing, that CDC doesn't work. I don't know why. Oh, is it even on the right port? No. That doesn't change anything. Oh, imagine the problem would be that we don't use a crystal. Oh shit. Nah, that should be good enough. USB config. UART init. deal RX, deal TX. UART 2. No, I don't want that. I don't want that. We might need a proper crystal after all. No, I hope not. I mean, the other WCH ICs have also internal oscillator or whatnot. That would be bad. I don't have a crystal on that device. Shoot. Pull-ups on the data lines. Why get? I can check. It has a built-in 1.5 resistor device mode, and no external pull-up resistor is required for specific configuration. Description, USB reset, force reset, boost reset, protocol reset, blah, blah, blah. Nah, it doesn't require anything external, apparently. Oh. Yeah. I'm not using the external clock. That wouldn't work because it falls back to 8 megahertz internal one. Okay, that's the reason, most probably. It uses external 96 megahertz, and I want to use internal 144. Here we go. I still didn't hear anything. Wow. Where is it? Wait. Did I close the data? Oh man, Geräte Manager da. No. I don't see anything happening. Nope. Did it update for some reason? Okay, let me check. Andere Geräte. Okay, bits, whatever. V. That's the RISC-V version. That's V. There is no like reference manual for yeah, that's you mean because of the datasheet? It's for F version and V version. There is no FV, or am I wrong? Because it's like Cortex and V and the blah 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 RISC-V. That's basically, it's the same chip with a different core apparently, but I don't see. Let me check with the dev board, because the dev board is over here. We can test the dev board and see what's happening there. If we get What? What's the difference? Board status error. What? Come on, board status. No error here. What? What did I do again? Let me... Oh! I'm not even connected. I'm trying to upload without being connected to it. Stupid. Stupid. Okay, here we go. Oh, well, I don't know what the pins are again. Nearsoft. Okay, thanks. That looks old school. Description. USB log. How do I? You installed USB devices on your system. Yeah, that's the V version, certainly. There, I don't think. Okay, I download this. If that even works, it probably links to SourceForge or something. Can't open it in this one here. This built-in thing. Okay, which pins are the debug pins on that device? I forgot. Clock. This is good. This is tiring. It's tiring. Okay, SVIO A 15 and 14. Okay, 15 and 14. Oh, no, wait. 13 and 14. The other one is SVIO 13, 13 and 14. 13 and 14, which is here. This clock 13 is IO, no. IO, clock and ground, okay. I should just open another link. I have more of those links. I bought a few linkies because I know that I break stuff. I'm aware of my flaws. That's ground. 13 is IO. And I can just plug it, unplug the other one, bam, and plug in this one, and then be good. Ka-chink. Okay. Now let's program it. Okay, here we go. That worked better. Uh-oh. Maybe we need a bot, my friends. No. Nope. Let me check if that works with system, with the external clock, like it was intended. I tested a serial thing. No. That might not be the right example. I don't know why this doesn't work. Let me check. Let me debug it. Let me do it for you. Start up, and this is not the main I was looking for. Yeah. Deal. Nah. That has nothing to do with anything. What is the deal here? What is the deal here with the USB? The CDC. Nope. I used one of the examples already with the USB. But that was a different workspace. Okay, simulate CDC. Let me check. Composite. What is this here? Device, CDC, and human interface device. What is that? You have both. Let me compile that and see if we can get another user interface device. What's that? Okay. Data RX deal init. Interrupts, USB config. Example routine to emulate CDViews USART. Nope, it's again similar thing. No, that wouldn't work. No. But where is the human interface device? HoloLens. Super speed. Is this only for power, or do I really need? Maybe I'm using the wrong USB port here. Auf der Grafikkarten. Oh yeah. Oh no, what is that? Okay, I need to get this this USB thingy listing device. download it, download it, download it, download the USB log view. Okay, here we go. Please don't have a driver. Oh yeah. Okay, what is this? Let me see. Ah, yeah. Okay, that's the link. You know what? It might be I might be at the wrong port. Let me check if I can use another cable. Yeah. Where do I I need a USB-A to USB-A port, even though that is not very common. I have a cable like that somewhere. That's not that. Hello. Where's my check? Yeah, that's okay for me. That will work as long as I see anything. But I need an USB-A cable. Or wait a second, I have a device that has USB-C on that here. Yeah. That's the same IC. Here, that's dev board. Uses USB-C. But oh no. I need to program that again. Shit. USB-A cable, where I had it. Oh yes, the drives. The old drives use like USB-A cables. And what does that mean? USB-A. The old drives. The old USB HDD drive. Yeah, that's what like the worst case is. But the best case is that the host isn't very picky about the clock. So I mean, they have to sync anyways. Oh, by the way, did you count in that the USB works at 48 megahertz and the internal one? Yeah, but the internal one works at 144 megahertz. So the deviation for 48 is way smaller. Serial print device name. Okay, yeah. Where do I have like this stupid? I never find. I need this USB-A cable. This is not. This is USB. Oh, come on. Ah, so yeah, okay. It was a nice try, huh? But I mean, you calibrate. Yeah, it's a hit and miss. Okay, it will. Jay, you know, I wing it. You know me. If it works, it works. If it doesn't, it doesn't. That's how it is. Shit. Okay. I will use that one because it has like also USB-C, but I need to solder on quickly a connector to the programming pins, which are here. Oh shit. I hate it. So we have one with clock and pins, because I think but you know what? That looks like it still has the connections here. Should work. Wait, we try something, a different USB example. I think that should still work. USB device. Yes, I can. But I'm using now the dev board and I still don't see anything. So let me try to get. That's a new disk example. Wait. Maybe I programmed along. Yeah, they did. But I didn't, and I don't see anything appearing on. Let me check that. Some USB 1. Please kick me. I connected it to a port on my front that doesn't work. Shoot. Oh man. Okay, let's see. Ah, do you hear that? That's my dev bot even. That appeared. Okay. Now we will see. Oh shit. It was connected to a stupid port that is somehow internally not connected, only the power. Oh man. Yeah. Please erase the past minute from. No, but I don't see it. What did we program on that? I don't see what appeared there. Oh wait, we have this plug unknown USB device. Descriptor request failed. Okay. Oh yeah, okay. Okay. So that might be the clock mismatch. Let's try again. Nah, unknown. Oh, that one didn't even show up at all. Interesting. Yeah, evil. That one didn't show up. Yeah. Interesting that the UDisk thing doesn't work here. Simulate CDC. Okay, let me get that one on the dev board. Let me try the dev board here. Nope. It seems like the dev board isn't even responding here. So I hear something, but I will re-upload this amplified mess that I do here with the CDC and hope. Let's see. Maybe I don't think that will be board chip error. What? Oh yeah, it's the wrong device here. Oh yeah. Why did I rebuild all? Okay, device showed up, but unknown device. Unknown device type. Request failed. Device descriptor. Oh no. Jay, please. Low speed USB probably. Where is the terminal? What? Where do you see terminal? Low speed USB. Where do you see that? Ah, yeah, what did I... Yeah, you jinxed it. You jinxed it. Now our stuff is doomed to be not fit for be running at... I'm wondering... No, that should work here. I'm wondering why this dev board doesn't work. It should appear as a device. USB device descriptor failed. Fool. Okay, I plugged it into the different hub now. Shoot. Okay. I connected it to the USB. Oh, yeah. Let me try something else. Let me try to put like a low speed USB hub in between. Low speed USB hub in between, so we don't have like expectation for high clock precision or whatever. Where's my... Do I have even a low speed hub? Terminal tab ls USB. Okay, let's check it. Nah. PowerShell. No, I don't have that. That's unfortunately. Oh, okay. We can do that. No, that's only. Clear log. Yes, clear log. Let me try that. System. Okay, I will solder on this device here some legs, so we will get a comparison to a device with actual. Do I have even? What? What's going on? Let me quickly solder it for you. Let me quickly solder it for you. Oh, I have so much space now. Okay, wait a second. Look at this. Look at this. Look at this. I threw the stupid stand away. There is nothing here. There is only this VESA mount on the wall now. Mr. Johnny Bagdal told me to try that. Now we have here microscope on this VESA mount, which is cool. It can be even lowered and high. Okay, it's not optimized yet. But I can work with that. Yes, please. Oh yeah, Mr. Shiny. Nice. Cool. Ha! Okay, let me solder that quickly and then. Do we use the evil solder? Yes, we use the evil one. Boop. Up. Boop. Oh, the ground. Oh, it's like, oh, I can move my arm here. Oh, look at this. Not really. This is made like the mount is made for 8 kilograms, and this whole thing I think it would shake, but it's really not that bad. I bought it for $40 from Amazon, and I thought if it doesn't work, I will just send it back. But I must admit it's good enough. It's not like I'm resting my whole. When I'm talking, it might shake a little bit for the camera, but Usually I'm not resting my head on this microscope, so it's really fine. It's working really well. I can work with that certainly. That's really cool. Now I'm looking for the... Oh yeah, it's not... Yeah, oh yeah, that's true. That's the best. It's on the wall. Yes. Yes. But when, I mean, if I bump it with my head, it will still shake. That's true. I'm almost there. Few more pins. Yeah, but Johnny got this idea for someone else. I don't know. I don't remember who it was. Yes, it is. Yes, it is. So it has an Allen thing here that you can adjust, and you can adjust here to like make it more stiff. And here the only thing that you can't adjust is the rotation here. Like, oh wait, not this one. I drilled like 2 holes to somewhat mount it, but this rotation isn't like, but it's very stiff. That's cool. Yeah. I lowered it, but I think I had a different mount for the camera. That's why it's not adjusted for that one. It's good enough for now. That's why I'm not changing anything. Okay, this is 14. Let me A14. Where's A14? This is A14. A13 and ground. Okay. New dev board, new luck. Here we go. Dudes. Now we find out that I need a crystal on my board. Foo, if that happens, because I don't have the pins for the crystal. I mean, for full speed, that's actually, yeah, bad, but it might just lose some packets, but I mean, that should really work. I don't know what's going on there. Okay, CDC, let's program it. Yeah, that's what everyone says, but we used WCH ICs without crystal before. Does this say anything about crystal? Crystal. Crystal like a Christ. Oh shit. Crystal. Oscillator. Does it say anything? I can find. Wait. Oh yeah, there's no power. Yeah. I can imagine that. Okay. Yeah. Oh, shit. Oh, no. Shit. Yeah. Yeah, but the clock is jittery. I know it already. Oh, damn. Ah! It should be pre-calibrated, the clock. It should be, but we don't know actually. It could be like just overwritten with zeros. Damn, that's bad. That's bad news for me. I mean, I might have like just connected something wrong. The plus, the minus, let me check. What does the bus say? Wait, what do I have here? I have SBO, blah, 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 that's not necessary. D and nope. Reset. Where is it? The NDP. Wait, Paul. Yeah. It just has to work on this one here. Just this one once, because that's my dev bot that I want to talk to. That's actually unfortunate that it works now on this dev bot. So my camera falls over. Here we go. Zip. Should we try to calibrate a clock? Yeah. I like that. I like that. I like that. This is, you are the way you are, and that helps quite often, because I mean, oh no, yes, the real is, and it's unflug doesn't worky. No worky. Muse nano chv. I might want to test. You know what? I might want to test if there is like. I don't think it might be. Is it open source? This design. But it looks like there is not much to it. No, that's just USB here. Yeah. Doesn't have UART or clock out. What do you mean? We can specify, we can just do a clock out on clock. How do we generate a clock? Man, this is terrible. Okay, I could imagine low speed would be good enough, but I want to try something. I want this USB hub. Where's my USB hub? I have an old, oh wait, I have multiple USB hubs. Where are all my USB hubs? Where did they go? I need just one. Okay, this is USB-C. I can't use that. I want to see if we can make it work with any USB hub. Or if it's just like really, really bad. And we can try to find the right clock calibration. Nice try. This is not the box. Oh wait, this is usually where I keep like stuff that's useful on daily basis, but the trash drawer, there is nothing in. Not here. Oh, you want to see something cool? This is the forbidden plug. You see that? This is how you make your laptop power supply flat. ChatGPT, where my USB hub is. You have ideas, my friend. I don't know what you mean. What are you talking about? Everything is all right. There is nothing to see. Okay, I will check the one thing. There is nothing happened. There is nothing to see here. I used VGA code to adjust already the clock. I need just to find it. Yeah. It's terror. Hello, Lomolo. No, a long time no see. The door is, yeah, I had a pizza just before the stream, so I wasn't feeling like fondue today. But there's plenty of fondue in my fridge. It's waiting for the next streams. Oh, bitluni slab. Yeah. But I want the code. Let me just get the code for the enter. Which code was it? What is that? Stupid. Why? Why doesn't it open? Okay. Plenty. This is my GPIO code. Wait. What is going on? Are you confusing me? DMA channel. Ah, that's what we want. That's a trim. Okay, we can just use our code to adjust it, because we have more or less a precise. Yeah, we can enable the output, but wait. Cluster base main CPP. Okay, this is where we can do the adjust. Oh no, usart printf. No, we do that. Trim. I hope this is that will work. Yeah, RCC control. I think the register should be the same as on the small one. We can use that for trimming. But now I will get an output for the OSCO. I don't think I have the pin available on my dev board, but I can use the bus to clock out, as we just do 100 and do the tick counter, so we get some clock. Okay, and you know what? We can do. Wait. Yeah, now we need a cleaner clock here, which will be bus state, GOBD bus out, bus in, clock out. Okay, here we go. I will just hack something to get something. Hey, wait. Something out the GPIO, which will be clock out. That will be time and 1. Okay, here clock out. We will should get a clock that's command out, bus out. What is the trigger? Source is 1. Now there is still. Wait. Init program. There shouldn't be this delay here. It returns. Oh. Yeah, we have a compilation error. Here, wait. What? Okay, here we go. This is the best we can get. Like for now, 3 point. Nah, okay, this is the jitter we. Can you even see? Bandwidth limiter. No, that doesn't do anything. Trigger. Yeah, the trigger is shitty. Hey, Anna! Yeah, we're trying to debug my shitty USB stuff. Okay, the precision, the measurement isn't very great. Yeah. That's not great. How do I that's what's this measurement? What there's like from what did we change that? Why is it, oh wait, why is it so slow even? We have like 256, oh yeah. Wait, that's like 256 clocks. We get you know what? No, wait. Where's my supercluster base? There. That isn't even true. How can it be if we divide the clock by 256, like here, at 144 megahertz? That's not a clock. I don't know what it is. Yeah, what's wait, is this one connected? Yeah, that should be, yeah. Okay. That's funny, you have German voice activated. Why is it that fast then? Yeah, and divided by 2 because we are flipping. We are flipping even. Huh? What is going on? I have no clue what is going on here. Are we even compiling yet? No, this is all right. Trigger, wait, no. I hate the cursors. I don't want cursors. Go away, cursor. 300 nanoseconds. It's a 3.27 to 2.8 megahertz, which is a little bit strange. This is awkward because oh yeah, I know what happens. I don't clear the timer. Here we go. Ah, I didn't clear the flag. That's the issue. Yeah. So back to the roots. Here, I didn't clear the interrupt flag. Ah, this is what we. Yeah, 280, which is almost spot on what we would expect. 280.1, 281, 281. What did we expect for? No, that's almost as that should be all right. 562, 5, 6. We are a little bit above that. 2.5. It's let me get maybe I can get a faster rate here. So we okay. 5.6. Okay, now we got only 5.6. 5. What? No way. We have now 5. That's what you said before. 562 divised. Okay, we have exactly 560 kilohertz, more plus minus. Yeah, more plus 0.5 kilohertz. What's our target? 62. So we need. Hey, I'll be DNC. Recap. Okay, the recap is that we increased the speed of our cluster so far, but now we are trying to get USB of the baseboard working without a crystal, which is not very nice. And I try to maybe adjust the clock a little bit. So we have the possibility to trim the clock. And I need 44. And what's the tolerance? That's not much. That looks good. Okay, no. Yeah. Okay, we need 5, 6. Okay, I will try to get it better so we can accommodate the jitter. But for me, it looks like it's only 2 kilohertz off, which is like. Okay, I will try to trim it. Let's see what happens if we set the trim like that. I will try to like hard code a trim. Okay, that's faster. So that's faster now. That's over the board. And now I will try to adjust it a little bit. What is this? Yeah. We are too fast, so I try to get it lower. That's too slow, but we are closer. Ooh. Binary finding, yes. Okay, we are 6. We are jumping around now. It looks like it's less stable, but we are closer to what I think this is the closest we can get. 562.8 is the highest, and 561.3 is the lowest I could see. How do I measure? How do I get a measurement for that? Like a good measurement. Measure push. Okay, that will do it. Okay, so we need to get this into our CDC example here. So we will put it in here, and we need to this is this is still external. Do forget to do what? Hello, Christopher. What did I clear a bit? What? I think all good, all good. Okay, that was the sound. Unknown device, not good enough. Maybe there is something else wrong with my board. Is there anything I need to do to make it work? What do I clear? Where do I clear something? Last bit of code, what do you mean? No, this is just the first line. That's all I need to trim. That's all I need to do to trim it. That clears the setting and that sets it. Yeah, that doesn't matter, the priority group. I can still move it, but I had also 3 beers today. Made me really sleepy. I had a nap. Okay, it was 2 Radler and 1 beer. It doesn't. Unknown USB device. Descriptor request failed. Unknown, product ID 2, vendor ID 0. Could be like a different issue. Yeah, it could be. So what I'm doing right now is I'm trying to get USB to working on my base board. So on my supercluster board, we need USB. So I'm trying to debug that. I am replying an ID that it doesn't understand. But let me check. No, I don't. No, it's just CDC, not human interface device. It's like there code. No. But we are using the same code. PS overall RMS picoseconds. What? No. Stop. It has nothing to do with the ID. It has only to do either with the clock or with the circuit, because it works with the other dev board. I can check the other dev board if we missed a thing there. Do I have a USB? Oh, wait. I can try. I unplugged my no. No. No, it's not the other board. It's okay. So I tried to plug it in now in USB 2 port, so I can see if something else, but no. Unknown device. Okay, that's not working. Okay, I need to check with the specs, with the reference design, but this is. Let me check. What is wrong levels? Wrong levels. Now the IC runs at 3.3 volts. IC runs at 3.3 volts. I can check if there is anything that I missed. Okay, I need to this one back. Yes, yes, it is. There is nothing in between except for two vias. So we have USB the USB D plus D plus D plus D minus. Oh, what I can try is flip. No, that wouldn't help. Flipping the USB cable. Nah. If there is an issue. No. No. But I tried to connect it. You can get open source monitor discovery software with built-in decoding. CC1 and CC2. What voltage do I need to set the CC1 and CC2? Any suggestions? We are at circuit debugging for the USB stuff here. Oh, maybe I should go for not for full speed, but for some sort of lower speed connection. Why not? Isn't there like priority? Let me check. USB time UART. USB init interrupts config. Yeah, but this is the same code that works with the other dev board. No. It doesn't have anything to do with the code. If the electrical something bad, I flipped the D plus and D minus or something. That could be the only thing. So, but nice suggestion here. Control speed. I just check now if I can change it to like lower speed or something. Like nicht. Yeah, that's what I tried. I trimmed it to be within specs, but the jitter is a little bit high with that one. Okay. Yeah, but I connected it also to USB 2 and it wouldn't work. CC1 and CC2 is only available on USB 3, USB-C. So it wouldn't matter. It doesn't work with USB 2. Man, okay. Let me check. It's a little bit frustrating to not be successful today with that. Let me just check if I can find the schematic for the oops, wrong window. Schematics for the I have the reference design, but the reference design didn't work either. Didn't even show up, which means there could be some stupid configuration issue. What could also happen? Oh, yeah. Oh. I have an other issue with this board, that the oscillator part, like all the A pins didn't work, but that doesn't have anything to do with the other one. Okay, I found a schematic for that one. And what we see, well, I can zoom in. Okay, let's download it. Mesomosi, well, boot select that. TF card, SPI, power. V-bus, there is a fuse. 3.3, 10 microfarads. I mean, I could try to get my laptop here, or like a really crappy laptop. Where's my crap top? Yeah, let me get my laptop. It's upstairs. Be right back. You can try to connect it there and see if that's more tolerant to our antics. We can connect it to the Ouya. Isn't there a new firmware for the Ouya? Okay, here we go. Oh, I hope I didn't lose TTS. Tap to return. Oh, foo. I lost connection to TTS. Crap top. Can't connect. What is that? Huh? Oh, here we go. Okay, let's see. Let's see how that's working. Oh. It work? Okay. Okay, device manager. Let's see if there is a unrecognized device. Okay. Oh, wow, there's a lot of stuff. No. Wait. No. Huh? Ah. I need that same software again. What's the name of the software that we downloaded here? Hey, Brian. Kids in bed? Sleepy, sleepy? Near soft? Okay, yeah, near. Oh, there it is. Yeah. USB. Ah, how was your day? Share with us. Oh no, wait. And the utility name was log view. Oh, fancy stuff you did there. Oh, I didn't ask you. Rope skipping. What? No. Oh, you are crazy. You're probably completely wet after that, like sweating like crazy. Yeah, no, that's all right. Oh, and also, how was the presentation you were in Dublin for after the meetup? Did everything went well? No, you were reporting about that. Something went wrong. No. What was no. Ah, come on, where is it? USB lock. What part number are you talking about? Yeah, that's easier. Just sabotage him. Sabotage him. Oh yeah, the okay. The main MCU is CH32V03. That's the one. Oh. But okay, log view. Nah, unknown USB device. I don't see that working. Okay, let me try the other one. the other port, but I don't see that working for some reason. Nope. Unknown USB device. There could be like also a configuration thingy that you have to do with like fuses, the fuses or the user bytes or whatever. But man. Yeah. No, not both boards. I'm both computers say unknown USB device. I'm wondering if I should try. Oh no, I don't want to assemble another board right now. I could. Oh, I have an idea. I have an idea. I have an idea. I have another board here. It's not exactly the same model number, but half marathon. Do I have a one with programming port attached? Well, it could be. I don't know. It has plenty of stuff. Where's the, oh yeah, here. Okay. So let me try to get this one working. I have a similar device here that we could try. You are evil, huh? Do you know Brian? You know Brian's address. You bought stuff from him. You can just send him stuff. Ha! You are evil. SDIO ground. Ground. What is this? Reset. Okay, I have a different device now that what? Why did you do that? Okay, I have a device now connected. Let me change. Oh yeah, okay. I have now board chip error. Ah. Clock. Yeah, that should work. Board chip status error. Board chip status error. What status error? What is? Oh, it's not plugged in. Okay, friends, now I connected a different board. It's not that. It's another issue. I show you. It's something with the MCU or the design or whatever. So I got this board. You remember the one that. So it's the same family, a slightly different one. It doesn't have any crystal, and USB shows up. USB serial. Oh man, it's getting late, but I'm wondering if I should just assemble another one of the boards, just test it. Something's off. That one works. Yeah, of course I have. It works with that one. It just works. You see that? Here. There. Do you see that? Do you see that? We can communicate. 15. Here. Let's type. Can we send something? Hello? No. Can we type there somehow? Open terminal, disconnect terminal. Can we type? Toggle input field. Let's do hello. Oh, you can see that, huh? Let me move that over. Let me move it. Here. Here. Let's do. Oh. Oh, it doesn't reply or what? I do not know if it's working. What does it even do? Wait, control state, simulate CDC. What does it do? RX, TX. But then, oh, it does a printf. Yeah, but printf my ass. How do I printf something there? Use USART. If you need to modify debugging serial port, please do not use USART. Just printf here. Printf. Okay, here we go. Compile. Upload. That one is closed. No, I don't see anything arriving here. That's debugging at the other port. How do I change the printf port? How do I? This example is stupid. It doesn't show anything. What's the UART? Printf. Format arc UART. USB init, data tx init. How do I send stuff with this UART? Struct attribute UART C. String G debug. Wait, where is the volatile attribute int t buffer? I don't want that. Param init tx deal init. Where is some kind of sending functionality? That's only like. I want to see it working. Okay, let me check this one here, the other example. I don't need the trim here. What does this example do? It takes long to compile. Let me disable building phase so you have more visibility. Okay, so this one is closed. That doesn't show anything. Okay, but what kind of init interrupts? Baud rate, UART. Okay, UART2 buffer, UART2 deal init USB clear flag clock command. Receive data printf init. How does that work? For debugging, if you need to modify debugging series, users match hit devices using endpoint downlink. Where? Where's send data? Send data. Send data, and then there's the USART type diff UART. But that's like, I don't know if this is. No, I can just take. That's type. Because that's UART and then data, and what's the data? What was the type? Uint data. Okay, let's do that. No, it's not. It's probably not. That's why. But we have this hit interface as well. Yeah, that is all right. That's working with. I mean, I have this circuit. We can compare the circuits, okay? That's a little bit different MCU. It's a higher tier, but it's the same class of MCUs. So I actually don't know what's going on. I don't. Do I have a debug device for USB that I could plug in between? Maybe Brian's power blogger. No. Um, yeah, that's working on one that I did also myself, which is using the same USB connector. Wait, okay. One thing, there might be a short between the D pins. Let me disconnect everything here and check if I have short there, because that could be if I have like a solder bridge or whatever. I want to see it. Do you want to join me with the microscope here? I might. That will be cool. If that's true, it could be. It will be awesome. No, wait. Oh shit. Do I do that? Okay. And I let you join on my journey here. Where is the micro? Yeah. Oh, that's too bad, huh? Okay. Why is this? Please tell someone stupid OBS that it shouldn't resize the stupid pop-up windows. I hate this. Just because I have 4 screens, it doesn't mean it needs to scale a pop-up window to all 4 screens and then resize whenever I try to move it to another screen or whatever. I hate this. This is like Windows crap. Okay, here we go. Let's check it. Let's check what we see here. That looks like it's not it. I should take off. Maybe I should also take off this. Yeah. It's not easy to unplug my tile. I should just remove the tile. Maybe the MCUs are drawing so much current that it's too low power for everything. Okay, let's see. Enhance. Oh. Oh. Wait. It's a little bit difficult. No. That's looking good. Is this even the right port? Yeah. That's all clear. This one as well. Looks perfect. Let me check the MCU. Yeah, that is the USB here. That here should be the USB differential pair. That looks flawless. There's my board. By the way, this board, I needed to put it there because yes, I could also just connect. Oh no, I need a few components there. Should I assemble just another board? Let me check if I see anything obvious here. Because I had problems with a few pins on that one already. But it takes a little bit of time to assemble that. Okay, let's test me. There is the OCD trigger. You mean this here? That's power. That is all right. Both VCC. That's always shorted. So you can see also on these here. Yeah, wonky. Okay, less enhancing here. Yeah. Oh no, it's way too bright, huh? Wait. Oh. Yeah. Yeah, it seems fine. Let me try without the. Now, oops, camera almost. Ah, everything. Ah. Well wishes to. Oh, what's going on? Huh? Jay, are you leaving or what? Let me just try to. You mean on the. Let me just plug in the board without the other one. No, unknown device. It's just the board without. Good night, Jay. It's the board without any components is already wonky. Maybe it's the power line. Should I check for the power line how that looks? Maybe this is like super noisy, but it didn't look like the signals were noisy. I mean, I used a different voltage regulator here. Okay, I can check that. Crotch cam! Nah, it's all good. Perfectly fine, noisy, 3.3 volts. There's no issue here. Okay. My dudes. What do I do? I think I proved the point. I proved the point that USB works with, okay, we didn't see it actually working. We just saw it connecting. That's all. We didn't see it actually working. We don't know even how to send data. This is terrible. Another very unsuccessful stream. How does that communicate? Don't we have an example that communicates? Simulate CDC compatibility, keyboard, mouse. What is compatibility hit? User bytes, or wait. So I show you extended configuration maybe. Here, slots and slits. No. User option bytes here. Okay. User option bytes unlock. Okay, unlock. User option bytes programming. User option bytes read protection. Write protection now. Where is the registers? X register description. No. What? Did you see some? No. Wait. USB internal pull-up I saw there. Where? Oh! Foo! How? Why? I don't have one on the other boards. What? Low speed, full speed mode. Oh yeah, there are also. Yeah, full speed, low speed. I don't want to low speed here. Enable, no external pull-up resistors required. Why? Why does this one work and oh no. Okay. Peeps. I have a programming tool that could be able to set these fuse bytes. Otherwise, we need to do this ourselves. Let me check. Where is our utility? What? Don't you see that? We need to try that. It's by default disabled. It's, oh, you don't see that. It's disabled by default. But it says 0. Ah, you still don't see. It says 0. So I just need to set this to high. And I have this utility where I can check that it doesn't say, let me check if I can, oof. Okay. Oh yeah, I need to plug that in. Okay. Oh, flash size. It's almost 500 kilobytes. What? 500 kilobytes is more than enough for everyone. That chip is cool. That one, even the one that worked, has even like, I think I will completely swap to that one because that has even Bluetooth, but I didn't put on an antenna. Is there, oh, data 1, data 2, what is data 1, data 2? Clock speed high. But wait, this is, this is not a user byte, is this? Extended control register, okay. Nah, it's not flash. And it's only reset when system reset occurs. Maybe I can just write it right now. Wait, from the code. Wait. But it would be strange that we have to use that extensity R. Okay, let me check that. We need to go back to this device. I don't need that clock. That's stupid stuff here. Always stupid stuff. Oh, you think they might be just commented out there. Yeah. I can just activate them, whatever. What was this? Extend CTR. Extend. Under trim, can I find it here. USB lib. How do I search there? Peripheral. CDC. Nah, that's also, yeah, in user. Hardware config. Pin in IPU. What is USB sort? USB port set. Where is this USB port set? Ah, wrong. Where is this used? P property. Hardware config. Oh man. I'm sorry. Prop config. Okay. Thanks. USB-D in it. When is that happening? You know what? F this. I don't know when or when this is happening, but I will just get what was we were searching for before this one. I will just do it. Yeah, but you know what? We can just try it. Extend theta, just setting it in the main here. Why not? Just to test it. We compile. Yeah, unknown. 39. Oh. That's why it compiled so quickly, huh? No chance, yeah. Nope. Oh, okay. I have no clue why this one doesn't work. Yeah. I just put it everywhere. Hey, Michael. Yeah, we have problem with the USB port on this my super computer here. doesn't work, and I'm done for today. I'm really tired. I got up like at 6. Everything. No. It seems not. There's something messed up with the board design. We can take a look at the. I mean, it's a different chip than what we used before. We can compare them. I can show the schematic for the other one. Let me open it. PCB. Which one is it? Cluster. This one here. Okay. Oh, we should not. Yes. Yes. Okay. Yeah. I'm not. I didn't give up yet. I just compare it. But good night. You're leaving right now, huh? Okay. Yeah, Charles. Okay, let's look at this. Okay, minus and plus. We have minus and plus. Minus and plus, 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 the minus and plus, minus and plus, minus and plus. They're directly connected, no vias, all good. Works. No extra stuff. What I can do is the other design. Here, supercluster. Oh, I changed the name, negative and positive. Maybe there is an issue with how I. Okay, positive is on the right. Positive is on the right. Negative is on the left. Minus is on the left. Here like that. It's similar like with this U, but different way around. It's all right. So CC1. What do I do with CC1? Oh yeah, CC1. Oh yeah, 5. I use that for 5.1K for the voltage. That's all right. Then we have, okay, this is that. Now I need to check if I am right on the pins here. Maybe I messed up while doing the footprint. 32 and 33. Let me check that. Boop, boop, boop. Data sheet. Data sheet I need. Did you check? Nah, it's correct. It's correct. You checked it already. Okay. I have no clue. I have no clue. No. Okay. Yeah, you just made a note. Okay. Data sheet for that one. Okay, noted it down. Specs. Where are the pin outs? Here are the pin outs. That's the 100 pin version. Strangely not available yet. 25, 23, VC 100 pin version isn't available yet. 64 pin version, that's the one, I think. Yes, that might be the one. 30 now. No, that's QFN. Is it? RCBT. Wait, which one is it? RISC-V that's the one. 48? No. Oh, come on. Need to check. Which one is it? C whatever T6. Yeah, that's the one. Okay. Uh, 32 is minus. Yeah. And 33 is plus here. Yeah, it seems, yeah. I/O. How did you via I/O power? VDD and VBAT power. That's interesting because I don't get any voltage on these pins here. I don't know why. Because usually you don't need to connect VBAT. I just need to solder a new board and see if I destroyed anything inside. Should I swap the MCU? I can reflow that quickly, and we can check if I can get a different result for the same problem. Do I have even more of those MCUs here? Yes, I have spares. Okay. That will happen quickly. No worries. Oh, I can give you a view of that on the mic. Okay, good night. Thanks for your help. I appreciate any support, even though my designs fail. Should we use some flux? Ah. It looks like it's not very in focus here. Oh well, good enough for me. It should be low temp solder paste. Oh, I have no clue which pin was where. Foo. I need to check in schematic. I don't see the marking. One is there, okay. Hello. You are right for the party where we replace this MCU to see if we have any influence on the outcome at all. Ah! Oh, this is a mess. Like that? Is that right? I think the pin 1 is there. Yeah, I will help with the soldering iron from now on. I think this is right. Okay, yeah. On the camera it's upside down, so it's a bit confusing. I will just reflow a little bit with the... Okay, here we go. A bit more flux, a little bit less light. And a little bit less temperature here on the soldering iron. I need some low temp paste. Someone's writing. Oh, this is not, it's not in focus for me. Okay, here we go. Oh no. There's certainly some shorts. Okay, I will just distribute the extra solder somewhere else. Don't want to mess with my botch, which is really nicely made here. Oops. Uh-oh, I bent the leg. Okay. Okay. I only need to get rid of that. Ah. More flux. Cleaner tip and more flux. Here we go. Okay. I think this is good. Now, let's see if we did any impact here. Oh, it's so cool to having the microscope working again, just for you, so we can have fun together here in the labs. Now we need to reprogram this newly attached device to see if there was an issue with the MCU, which could have happened while connecting a shorted MCU somewhere. Let's see if we can make a difference in being a goof right now as we speak. Compile, compile. Okay, let's go. Okay. No. Unknown. I flipped the table. It's not this device. It's not that issue. It's something else, and I don't know why and what and yes. It has even host, so it really should be. The bigger brother, which costs like 20 cent more, it has even like Bluetooth, and I don't know what's happening right now that I can't get this running. I mean, I can still wait. That's the heat device. Let me get this one here as with this trim that we even set up before, which I don't know if it's correct for that chip specifically. No, it's unknown. There is some hardware configuration. You know what? I will check out with on the Discord with the devs of WCH, because there is a connection, and next time. Oh, what? Someone sent me donation. Oh, Michael Wert, thank you very much. Oh, yeah. Yeah, thanks for the donation. I will check with the devs. I will see what's happening here. Debug it. And next time we will come back with new designs for extension cards with some proper bus and whatnot. Okay? Yeah, he went to sleep. Maybe he rewatches at some point. I don't know. Okay, peeps. Oh, thank you very much. I thought I would be sleeping like 2 hours ago. Next time with fondue and fresh power, re-empowered. And maybe we will also code this here, the mini game. Pew, 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 pew. Looney is too sober. Yeah. Do I look like I'm sober? This is crazy. I don't know. I should just go with these MCUs. It's QFN. They're also affordable, more or less, and it just works out of the box for whatever reason. Foo. Or it's my PCB design. JC messed up, and now it's always. Okay. Let me check what voltage I get. No, I can. Oh no, I can't test this. This is like. There is like this stupid connector in bit. Nah, I can. There is like. This connector is right next to it. How do I? Nah, no way I can test this. Okay, foo. I'm done for today. Thanks everyone for watching. Bye bye. See you next time. Good night, everyone. Where's the button to end this all? Oh, 10 people watching still. Okay. Bye bye. Oh yes, happy Easter. Happy egg hunt. Egg hunt. Egg hunt. Yeah. Gute Nacht. See you soon. Bye bye.